Hello everyone, welcome back to our channel. Let's discuss the next topic, that is factors influencing on vibrational frequencies. Already in the last video we had a discussion on the vibrational frequencies of different kinds of bonds in different organic functional groups, right? There we have observed that for some of the bonds vibrational frequencies are less, for some compounds vibrational frequencies are more. Why? What is the reason? The reason we are discussing in this particular video. Okay? Factors influencing on vibrational frequencies. What is the first factor? That is force constant. Already we have a formula. The frequency or wave number equal to 1 by 2 pi c into square root of k by mu. Here k is called as force constant. The mu is called as a reduced mass. Generally the mu value is equal to what? m1 m2 by m1 plus m2, reduced mass, the formula, right? If we have two atoms are connected to each other, then we are going to have this kind of formula, mu equal to m1 m2 by m1 plus m2. m1 and m2 are the masses of the corresponding atoms, right? So from this equation what we are observing, the vibrational frequency is directly proportional to what? Force constant or not? The vibrational frequency is directly proportional to force constant. Force constant measures what? The bond strength. The strength of the bond is calculated by using the what? Force constant. Right? If the number of bonds increases, what will increase? The strength of the bond will increase or not? If the strength of the bond will increase, force constant will increase or not? If the force constant will increase, what will happen? Vibrational frequency will increase. That's why comparing with the single bond, the double bond is having more K value and the triple bond is having more K value. Because of that reason, what we are observing, in case of the alkynes, the carbon-carbon triple bond vibrational frequencies are very much higher. Why? Because force constant is higher. Why the force constant is higher? Why? Because we are having the triple bond. Triple bond means more strength. So the K will measures what? The bond strength only. So for alkenes the strength is more. That's why the vibrational frequency value will be high. Okay, then come to the next one, relative masses of the atoms in a group. Already we had a discussion that the reduced mass mu equal to m1 m2 by m1 plus m2. It means that what? The mass value influencing the what? Reduced mass or not? Right? According to this formula what we are observing, see the relation, vibrational frequency is inversely proportional to what? Reduced mass or not? The reduced mass is directly proportional to what? Mass of the atom or not? It means that what? We can easily say that the vibrational frequency is inversely proportional to the masses of the atoms. It means that what? If the mass of the atom is more, vibrational frequency will be less. Okay, see this one. CH, CBr and Ci. From left to right, what is happening? The mass of the atom is increasing or not? So mass of the atom increasing means which one increases? Reduced mass increases. Reduced mass increases means vibrational frequency decreases. That's why the CH bond is having the higher vibrational frequencies than comparing with the CBr bond and then comparing with the Ci bond. Okay, next one is what? Hydrogen bonding. If you see, hydrogen bonding means what? The hydrogen is surrounded by two more electronegative atoms. Is commonly called as hydrogen bonding. So in case of the alcohols and the amines, there is a possibility of hydrogen bonding or not? So in alcohols we are having OH bond or not? Assume that OH bond is free in nature, OH bond is surrounded by hydrogen bond. So what will happen? In which case the OH strength is higher and in which case OH strength is lower. Okay, see this one. If it is the free OH bond, there is no influence of any kind of external atoms. That is what? Free. In case of hydrogen bonded, what we are observing, see this one, we are talking about this particular OH bond, but the hydrogen is surrounded with this oxygen and this oxygen. So oxygen is more electronegative atom or not? It means that what? The influence of two hydrogen atom, the influence of two oxygen atoms takes place on the hydrogen atom or not? So initially we are having this OH bond. This OH bond is having particular strength or not? This OH bond is having particular strength or not? Why? Because it is a free. Now what is happening? The another oxygen atom is influencing this hydrogen. It means that what? This hydrogen also wants to move towards that particular oxygen also or not? So if the hydrogen willing to move towards the second oxygen, what will happen? The strength of this bond is going to be decreased or not? The strength of the bond is decreasing means force constant value is decreasing or not? Force constant decreasing means what? Vibrational frequency decreasing or not? That's why whenever the atom is surrounded by any kind of the hydrogen bond, the vibrational frequencies will be always reduced. Okay, see this one, lesser frequency. The presence of hydrogen bond decreasing the bond strength. Decreasing bond strength means decreasing force constant. Decreasing force constant means decreasing vibrational frequency. Okay. What is the next one? The influence of hyperconjugation, resonance and inductive effect. Let us see. If you see the amide, I am talking about the frequency of carbon oxygen double bond. If the atom or group involving in the conjugation, see this one here, we have a pi bond. So because of the lone pair electrons present on the nitrogen, what we are observing? Conjugation or not? So because of the conjugation, the pi bond is converted into single bond or not? So double bond is converted into single bond or not? So double bond is converted into single bond means what is happening? The force constant is decreasing or not? Already we know that. For the single bond, force constant is very less. If the force constant is very less, what will happen? The frequency will be reduced or not? So it means in case of the resonance, what we are observing? The decrease in the vibrational frequency. Am I clear? Next. Suppose if you have hyperconjugation. So because of the hyperconjugation also, what is happening? The pi bond is converted into single bond or not? So bond strength is decreasing or not? Bond strength decreasing means K value decreasing. K value decreasing means what? Vibrational frequency decreasing. It means that what? Whenever we observe the resonance condition or the hyperconjugation phenomena in a particular molecule, the vibrational frequencies of the selected bond will be decreased. Okay? Then next one is what? Inductive effect. Inductive effect increases the vibrational frequency values. Inductive effect increases the vibrational frequency. Why? Because see this one, in case of the acid halides, if you talk about this C double bond O, here we are observing what? Inductive effect, or carbon is more electronegative or not? Right? So carbon, here chlorine is more electronegative or not than comparing with the carbon. That's why what happens? Always these bonding electrons move towards the chlorine or not? Here oxygen is also more electronegative element or not comparing with the carbon. That's why these bonding electrons always move towards the what? Oxygen. From one side oxygen is going to take the electrons, from another side chlorine is going to take the electrons from the carbon. Both are the more electronegative atoms. That's why what happens? The strength of the C double bond O is increases or not? Right? The strength of the C double bond O increasing, thereby what happens? Force constant value increases. Force constant value increases means what? Vibrational frequency value will be increased. That is the concept. So this is the example. Comparing with the conjugated C double bond O, simple C double bond O is having more frequency values. This is interesting. Okay, I think you understand the effect of different kinds of the situation. Okay, next one, field effect. This is one of the important point we need to observe. What we are saying, at alpha position of the polar group, if there is a electronegative atom, the vibrational frequencies of polar group depends on the orientation of the electronegative atom. We have a particular group at the alpha position. If you have a electronegative atom, that electronegative atom is going to influence the vibrational frequencies of the selected polar group. The polar group vibrational frequency depending upon the orientation of the electronegative atom. It means that what? This kind of situation is going to be observed in cyclic compounds. See this one, here we are having chair form, chair conformation, alpha chloroketone. The first case is what? At alpha position, the chlorine is present in the equatorial position or not? In the second case, the chlorine is present in the axial position or not? Already we know that IR spectroscopy is mainly deals with the compounds which are having the permanent dipole moment or induced dipole moment. It means that what? Dipole moment plays a original role in the interpretation of the structure of the compounds or not, according to IR spectroscopy. Here we are using that concept only. See this one, in the first case what is happening, we are talking about the C double bond O frequency, right? What is the influence of this chlorine atom on the frequency of the C double bond O? Here it is equatorial, here it is axial. See this one, here what is happening, the direction of the dipole moment of C double bond O like this or not? So in case of CCl also, the direction of the dipole moment in that direction only. So what is the net dipole moment? The net dipole moment is the sum of these two dipole moments or not? It means that net dipole moment will be increased or not? The net dipole moment will be increased. That's why the Fresnel frequency value is higher. But in this case what happens? See this one, in case of CCl bond, the vibration, the dipole momentum is like this. But in case of C double bond O, the dipole momentum is like this. So what is the net dipole moment? It will not be the combination or not. So the dipole momentum is less. That's why the Fresnel frequencies are lesser. This effect is commonly called as field effect. Influence of electronegative atom at the alpha position to the particular polar. Okay. Come to the next one, phase changes. This is also very important phenomena. This is specially for the samples which are in solid state, liquid state or gaseous state with hydrogen bond. We have three different kinds of samples or not? Solids, liquids and gases. In these three situations, if you have the hydrogen bonding, what will be the effect on the vibrational frequency? Let us see. The vibrational frequencies of the vapors are higher than the liquids and liquids are higher than the solids. Why? In case of the solids, what we are observing, the distance between the species are very less or not? The force of attractions are higher or not? It means in case of solids, if we are having hydrogen bonding, the strength of the hydrogen bonding is more or not? If the strength of the hydrogen bond is more, which one will be less? The frequency will be less or not? Strength more, hydrogen bond strength more means the force constant will be less. The force constant will be less means frequency will be less. That's why in case of the solids, the strength of hydrogen bonding is higher, so Fresnel frequency, vibrational frequencies are less. In case of solids, the strength of hydrogen bonding is more, that's why the force constant is less, so vibrational frequencies are less. Okay. Next, ring strain. Increasing ring strain increases the vibrational frequency. Why? Because the percentage of S character of sp2 hybridized carbon increases. Already we have seen in case of alkane, alkene, alkyne, CH stretching. In case of alkane, the carbon hydrogen is having lesser one comparing with CH in sp alkene and comparing with CH in alkyne. In case of alkane, carbon is sp3. In case of alkene, carbon is sp2. In case of alkyne, carbon is sp or not. So it means that what? From alkane to alkyne, percentage of S character is increasing or not? The percentage of S character increasing means what? The force constant value is increased. Thereby what is happening? The vibrational frequency value will be increases. See this one? The ring strain increases what? Percentage of S character. That's why this is the 3-membered ring, this is the 6-membered ring. So in 3-membered ring, the vibrational frequency of the C double bond O is higher. For this, lesser. Next one is what? Steric crowding. Here crowding also plays a very important role in the vibrational frequency. What we are saying here, sterically crowded carbonyl vibrational frequencies are larger due to the hindrance of the resonance. So what the people are saying, already we know that effect of the resonance. If you observe the resonance phenomena in the molecule, what will happen? Vibrational frequency will be reduced or not? Right? The same concept we are applying here. See this one? We are talking about the frequency of the C double bond O. This is the first situation, this is the second situation. In the first situation, what happens? The pi bond and phenyl group is moving towards the bottom, the C double bond O moving towards the upper one. But in this case, what happens? The distance between these two are very less or not? If the distance is lesser, what happens? The conjugation is going to be disturbed. Conjugation or resonance phenomena is going to be disturbed. Once the resonance disturbed means what? There is no change in the pi bond character. So pi bond character is there means what? Higher force constant. Higher force constant means what? Vibrational frequency higher. But in this case, what is happening? The distance between the groups are. In this case, what happens? We are clearly observing the proper conjugation or not. The proper conjugation is reducing the CO strength or not. CO strength decreased means force constant decreased. Force constant decreased means vibrational frequency decreased. That's why in this case, frequency more. In this case, frequency less. Right? Here we have one important formula. The frequency of CH bond by the frequency of the C deuterium bond, heavier isotope of the element, that is equal to √2. Right? By using this formula, we can calculate the frequency of the carbon deuterium bond if you know the carbon hydrogen frequency. In all the organic functional groups, whenever you are having the CH, for all the CH we have a particular frequency or not. It means that what? If you substitute that frequency, thereby what can we calculate? The frequency of C deuterium bond. This is very, very important in terms of the net examination. Right? Especially in the part B of net examination, we are going to get the questions from this formula. So, have a look on this particular formula and related problems. So, this is all about what? The factors which are influencing on the vibrational frequencies.